In this video, I'm going to write a computer program in C that looks at memory locations of various types of variables. And so this is the one case where you don't have to follow along and make your own program. Just watch and take notes. If you want to follow along, that's fine. I'm only doing this one on one platform. I'm doing it on a Mac, so if you use Windows, it's going to look slightly different, but you'll easily get the message, no problem. Okay, so what I'm going to do is I'm going to go in and start from scratch. I'm going to make a project called test point, right? And so however you want to do that, I get in there, and I click on the C file and it comes up in an editor. Then I'm going to add 4 variables, A, B, C, and D. So A is a floating point array 10 elements long. B is a floating point pointer. Right? And so if you notice, I'm going to printf what the memory address location is of B before I do the malloc, before I allocate 10 elements, and after. The way to look at an address in a printf statement is %p. P stands for pointer, right? And so and you can use %p for any variable. You just have to give it the address of that variable to print out. That's all. So you can see that before I do the allocation, there's one particular memory location, and then after I allocate a 10-element block to B, it gives a completely different address location. So that's an example of what I said in a previous video. So I'm going to declare A as a floating point array, B as a floating point pointer, C as an integer pointer, and I'm going to allocate 10 elements to that, and then I do D as a character array, 10 elements of the character array. Okay, so then I'm going to, then I assign a variable I and FP, file integer I, and then file FP, and I'm going to load up the data from o10.txt, that's 10 points, just random numbers, into, actually I'm going to load it into B, the pointer. If you look in the fscanf statement, there's no star or anything, or and or anything. You're just doing B plus I. That's the address. B plus I is the address of where B sub I is. And so you're sending the address to fscanf that way. Then below that, you can show the equivalence of how you assign the contents of B to the contents of A with an offset of I. So that's how that thing works. And then the printf statement below just shows that they're equivalent, shows that you're going to get it with the same number there. So far we've just learned how to use pointers in fscanf statements, what the convention there is, what the difference, and how to interrelate array values with pointer values. And we learned about in the malloc up top, we learned how to see how malloc reallocates memory. And then we learned how to print out addresses of variables. Okay, that's the main point that I'm trying to make at the bottom here. If you look, I'm going to print out the addresses of the 0th and the 1st element of all these different arrays, right, or pointers, right? So you can see if I look at the first one, I do A with no bracket 0 there. I just do A. And then I do ampersand A sub 1. Right? I could have done ampersand A sub 0, ampersand A sub 1. If you look down at the car D, I did that with D, right? If you give an array without any brackets behind it, it's the address. It's kind of the same as a pointer. That's pretty interesting. Wow. And so that's a notational trick there. And so when I look at the difference between the 0th element of the A array and the 1st element of the A array, you can see the difference in the addresses there. There's 4 elements difference. It's 4 bytes. So that shows you that a floating point number in the computer that I'm using is 4 bytes. Then same with B. If you look at B, the memory difference between B plus 0 or just straight B, and then B plus 1 is 4 bytes as well. And the difference in an integer is 4 bytes. So an integer also takes 4 bytes in this example here. A car, the difference between D1 and D0 is only 1 byte. So cars are smaller than either ints or floats, as you can see from that thing. Pretty cool. So that's how memory allocation works. That's how you can look at addresses and see what the value of an address of a variable is. And this kind of, it's in really, really sophisticated programming things, you might actually need to look at addresses and see what's going on with real live memory locations. So there's some actual practical knowledge here, but the main thing to learn is to actually see memory locations of actual variable addresses. That's really the point of this video.